Number one, we're going to find the solution of the system of equations shown. So the solution of the system is a point intersecting when we have two lines. So two lines intersect at 2, 2. So this order pair is going to be the solution. So this is consistent, right? When consistent, when there's at least one solution, it's called consistent. And when we have one solution, so the first case we have one solution, which is number one, we have only one solution. It is called independent. And if we have infinitely many solutions, then it's called dependent, consistent and dependent. And if there's only one solution, consistent and independent. So you have to put both. And if there's infinitely many, so if there are two lines and it's exactly same line, if it's coinciding, then you can say the system is consistent and dependent. Consistent and dependent. And if there's no solution, so there at least one solution, and if there's no solution, then it's called inconsistent system. So the line is parallel and they never gonna touch each other. There's no solution, there's no intersecting point at all. And let's look at number two. We're going to solve the system of equation by graphing. And you're going to have a calculator, graphing calculator on the test. So which means you can double check your work with the calculator. But let's just graph it using y-intercept and slope. Y-intercept is +1 and the slope is, everyone see here, negative x. Negative x means -1 times by x. So the slope is -1. And we know that we change the slope like integer into fraction form so that you see the rise over run form. Rise over run over 1. So it means what? 1 down, 1 to the right. So you're starting from +1. Y-intercept should be on the y-axis. And you go down by 1 and to the right by 1. Down by 1 to the right. Down by 1 to the right. And if you have a ruler, you only need 2 points to graph, to connect the points and to get the graph of the line. It should be straight line if you use a ruler. And now I'm going to find the y-intercept and slope. What's the y-intercept? 3. -3. Don't forget to bring that sign with 3. And slope is 1 over 3. It's already fraction form. 1 up, 3 to the right. So you start from -3 on the y-axis and 1 up, 3 to the right, 1 up, 3 to the right. So if you connect the line, connect the dots, and it will look like this. And double check with your graphing calculator, and the solution for this question is this point, which is 3. You always read x first. 3 and -2. So this is a solution of the graph. So this little box, this order pair, is the answer that I want you to put on the paper. So this is the answer. And this solution, if you plug this back into both equations in the system, then it should be true statement. So let's just put x, y, x's here. And the graph of equation have same slope, which means they're parallel. but different y-intercept. So one line is here and different y-intercept. So I'm going to just put it down a little bit, and the same slope. So they tilted the same way. The system linear equation described below. How many solutions does the system have? What do you think? How many solutions? No solutions. No solution. What about same graph, same slope, different y-intercept? Oh, is that the same thing? I'm going to change this question into this should be I'm gonna just change it to same slope but same y-intercept. All right, now I change the question, same slope and same y-intercept. Same slope, same y-intercept. So xy-intercept, xy-axis, and same slope, and same y-intercept. So it's going to be the same line, right? Because think about y is equal to mx plus b. They have same slope, same y-intercept. Then it's going to be the same line, right? So this is consistent, and dependent. It's going to be exactly same line. So there is infinitely many solutions because it's going to be the same line. There are a lot of points which makes this both equation true, right? There's a lot of points, all the points on the line. So infinitely many solution. What about different slope and different y-intercept? So different slope and different y-intercept for this case. So let's say the first line is this, and I'm going to choose different y-intercept, which is this, and I'm going to go down this time, negative slope and positive slope. So how many solution? There's only one solution for this case. Only one solution. Matching, select the correct answer for the following chart. So look at the line. So it's intersecting at 1 point, right? How many solution? Number of solution is going to be 5, right? For D, one solution. I'm going to just put one solution. So for D, you have to put 5, right? What about E? How many solution here? They are parallel. So there's no solution. So E is number 4. So this is gone. And F, you see the line is thicker than the other. That means you have 2 lines overlapping, which means you have infinitely many solution on the line, which makes this system true. So I would say infinitely many solution. So number 6 is for F. This is gone. And there's just intersecting lines. So A for 1 for A. What about B? There's the answer, parallel line. And then what about C? It's a coinciding lines when they're exactly same. So 1, 2, and 3. Which order appears the solution of the system? So now you see this equation is solved for y. So which means you can use this x minus 0. I'm going to just circle it too. X minus 1. I'm going to substitute this for y because they're same, and then we can get rid of one of the variable. So if you rewrite the first equation, it's going to be 3, and it was y, right? It's negative 1. But this time, I'm going to just get rid of it, and I'm going to replace with this, which is x minus 1. So if you just do distribute property here, let me just rewrite it. 2x minus 3x plus 3, not minus 3, negative 1. And then I'm going to simplify this. Negative 2 minus negative 3x, which is negative x, plus 3, and negative 1. Let me just solve for x. So you have x is equal to 4. Now you need to plug back into one of the equation. Let me do this. So it is going to be 3, and the answer should be 4, 3, which is B.